Hello everyone, this is Orhan Ergun again. Today we will talk about Internet Exchange Point. There are many things now. We will introduce the agenda. Brent with me, Brent Mc Intosh, and he will introduce himself. And as usual, conversation-based video you will see, and probably 1 hour, 1.5 hours, we will be together. We will start from the basics and we will deep dive also. We will understand what Grenada Exchange Point is doing. Welcome, Brent.
Hi, Orhan, thank you, and welcome to you viewers out there. It's a pleasure to be with you this morning.
Thank you. So, Brent, what you are doing, what is this peering coordinator? So, can you please introduce yourself?
Okay, great. So, as Orhan mentioned, my name is Brent Mc Intosh. I'm from a very small island in the Caribbean, probably about 105, 108,000 people, and maybe, 4 to 5 ISPs. But the Caribbean is made up, of course, of a lot of different islands, each unique. But one thing we have in common is that we share, excellent technologies similar to other larger countries, and we also try to, improve our internet ecosystem. So, in terms of what I do for GREX or the Grenada Internet Exchange, I play a critical role as the pairing coordinator. And the role of the pairing coordinator is to ensure that uh, parties like CDNs, ISPs, content service providers, and critical infrastructure can all connect with common policies on the internet exchange for sharing traffic, exchanging traffic. That role is really important because, the social engineering part of IXPs is normally a very tough role. Getting technologies in place is very simple, but getting people to understand the benefits sometimes can be a challenge because most times, especially in the case of service providers, IXPs are seen as a way of that can make you even lose revenue. But they're very, very critical and key functions that IXPs provide. And if you asked me this 10 years ago, when I was just getting into working along with pairing and connectivity for internet exchanges and ISPs, one of the key things that I used to focus on was the fact that we will all have local routing, and round trip times would be less, and end users would get better experiences or quality of experiences because traffic was being routed locally. Uh, ISPs in the past pretty much had two exit points in the Caribbean. For Grenada and other Caribbean countries, traffic would either go through the United States at Miami transit location or New York, and that's it, right? But now, with the whole advent of development of IXPs in the Caribbean, you can have traffic being locally routed for popular content from, Google, Facebook, Netflix, and, other top CDNs out there. And so now there are newer benefits to IXPs as opposed from just local routing and keeping your traffic local to your country. You know, um, for I worked, for a couple of the larger ISPs in the Caribbean in the past, but no, my key focus is on IXPs and of course, supporting enterprise businesses as well. So, that said, IXPs play a critical role, and in my role as pairing coordinator, I ensure that critical infrastructure, not just content, but DNS anycast services from, as a matter of fact, we host a couple E-root, D-root, and an L-root instance in the Grenada Exchange. And similar for the Caribbean exchanges. There are not many, but there are a few that are very functional and working excellently. And there are also some that are now being developed. And while they're being developed, their focus as well is to be, an IXP that supports critical infrastructure as well. Time servers, and DNS anycast, and some CCTLD hosting as well.
Okay. Let's start seeing those slides.
Okay, great. My pleasure. So I did a couple slides here, just to give you an idea what we do at the Grenada Exchange. And keep in mind, there are other Caribbean exchanges, but you would find this one, pretty pretty much gives a guideline as to what happens to other Caribbean exchanges. There is one exception, though, which is the AM6 Caribbean Exchange in Curacao and the Netherlands, the Caribbean part of the Netherlands, which is Curacao. They are a for-profit exchange. There are commercial services there, unlike this one in Grenada, which is at this point not for profit. So we're going to take a little look at the functions, operations, traffic exchange, and what's next for the Grenada Internet Exchange. So the key functions of GREX, commonly called the GREX Grenada Internet Exchange, is to ensure that we provide a common fabric, layer 2, layer 3 fabric for interconnecting ISPs, CDNs, other local content providers, and critical internet infrastructure, as I mentioned, like DNS and ECAS services. That'd be more root service instances. We run a parent model that is bilateral, non-mandatory.
Okay. At this moment, let me ask couple things, and let me also add couple things. So you said layer 2 and layer 3 fabric. I want to understand, do you have layer 2 fabric or layer 3 fabric? Most of the XPs anyway, layer 2. And I would ask you, are you doing the operation just with the VLAN, or I think it's enough for the scale? So as we know, M6 links, etc., they are using other, let's say, more scalable layer 2 technologies like EVPN, etc. What you have as a technology there?
Okay, excellent question. And so the base model and that fabric is actually layer 2. We use common VLAN for all pairing, and that's for all IXP members. But something I didn't mention, which is one of the things that we're really happy about in Grenada, apart from having an IXP, at a very close distance, we have what you would probably know as a micro data center. We also run a small data center very close to the Internet Exchange. It's maybe 10, 20 feet apart, pretty much buildings connected. And that aspect of it, we try to run a layer 3 infrastructure. So there is connectivity to that infrastructure, of course, and that infrastructure hosts local content providers. So that is a small aspect, a small component of that IXP/micro data center that is layer 3. But good question. Is the common VLAN is all a layer 2 service primarily. Layer 3 is.
Let me understand why you are not connecting those over-the-top providers, or just CDN maybe, to the peering LAN, but you are accessing through the layer 3 fabric?
Oh, so right, and let me clarify again. So OTT CDN providers are all on the layer 2 common VLAN. Okay. There are some other critical services that we need to provide for them as well, which is out of band management, cache fill for actually filling the caches with popular content. So we do that. Of course, that's all layer 3 because this is a separate parent fabric for them. So that's a very good question, and that's primarily why we run that layer 3 section.
So, okay, now I got the point. Just please clarify. All those, we will see, I think, the participants also, but let's say content providers and CDNs, they are connecting layer 2 guys to the ISPs and other members. They get from the same subnet, and I will ask also peering LAN subnet. Is it /22, 23, 24, whatever? So they are all connected to the same LAN. They get the IP address, and it is just layer 2, and then BGP session will be created between those. Probably we will see also route server here, so not full mesh eBGP I'm talking. They will be probably connecting. I don't know yet. I couldn't see, I think, in the slides, maybe in the infrastructure slide. So through the route server, they will exchange the prefixes. But for those content providers and CDN, their cache servers in that micro data center which you mentioned, and through layer 3, they access to their caches, and popular content is coming from that data center to the peering location, peering LAN. Okay. So far, so good.
That's correct. It's been years and years that a lot of providers have been trying to roll out IPv6, and one of the critical components of the Grenada Internet Exchange is to actually have a model that is fully dual stacked. So we do run IPv6 stack there as well actively. We do have providers that connect there at V6 as well. And, small country, but we want to ensure that the exchange is pretty much future-proof by providing, that dual stack connectivity for not only CDNs, because all the CDNs today are dual stack and, sharing content over V6, but also to ensure that providers can have the opportunity to connect at V6 and at least get some local content over that part of the IP stack.
Okay. Now, just a second. Can you go back to previous slides for those maybe who are very new to the peering? What does peering here? What we are talking about? Basically, business model which two or multiple entities. Here it says peering model bilateral. When it's bilateral, two businesses. It might be access ISP and another side content provider, etc., or lots of different, but two different businesses, different type of businesses maybe, but two different guys. Let's say my router is connected to your router, it's bilateral. If multiple, it might be even 1,000, like I think in M6 now we have over 800 people are doing peering in a same layer 2 environment. And we will see here there will be also many people join to peering fabric, we say, peering layer 2 fabric, and then they get the IP address and we create BGP neighborship between them. They exchange the prefixes. But which prefixes? Their customer prefixes. So they cannot advertise if they are receiving full internet routing table and they don't advertise to another. Peering mean here, we mention settlement-free peering, which means if two or multiple entities advertising the BGP prefixes to each other, they don't charge any money to another side. Okay? So because the idea is mutual benefit. Brent and myself, let's say we are doing peering, settlement-free, there is no money exchange with it. And what I am doing, my prefixes and my customer prefixes, I am advertising to Brent, and he is advertising to me his customer prefixes as well. So my customer is reaching to his customer. Maybe my customers are eyeballs, so actual users, and his customer is content providers. And traffic from my eyeball is reaching to content provider and coming back. And we see that almost same amount of traffic we are carrying, right? I am sending you 5 gig, you are sending me 5 gig, though this traffic ratio is another problem in the peering ecosystem though. So, but if it is mutual benefit we are seeing, and same size of ISPs or same size of, let's say, two businesses, we are exactly getting the mutual benefit, then why we are sending you an invoice and you pay me money? No, there is no money exchange. This is peering, settlement-free peering. When we say, for short, generally we use peering term. Now you start getting into peering ecosystem, guys. So, and here bilateral, Brent and myself, we are exchanging the traffic. If there is third guy, and if we are okay to do peering with him as well, so no money exchange, and he will send the customer prefixes, we will send our customer prefixes to that guy, then now even three guys, we consider it multilateral peering. Okay, so that's the idea what it's written here. This, I said we will exchange the IP addresses. Those IP addresses might be IPv4 or IPv6. Brent's ISP Grenada exchange point supporting both. So if both IPv4 and IPv6 we have, what we call it dual stack. Let's move on.
Okay, great. Okay, so I did mention a little bit of our operating model. It's non-mandatory bilateral pairing, and it's not for profit. The idea here is to ensure that local ISPs, content providers, can all connect and share their traffic and their customers' traffic for now, free of exchange, free of financial exchange. And our key focus is developing this IXP, even though it's small and hosts about maybe 15 to 16 entities, maybe 4 to 5 ISPs, is to ensure it sort of fits the model of the larger next generation type IXPs as well. Okay, so I spoke a little bit as well of what I do, but there are other roles at the IXP as well, where we have not just the parent coordinator, but we have stakeholder groups that are responsible for policy development, ensure we have the right policies in place for onboarding ISP hosts and entities. And it's a collaborative approach. There is nothing competitive there. As a matter of fact, one of the main stakeholders, and this is maybe unique for Grenada, but one of the main stakeholders there is the Regulatory Commission. And, you would hear in a lot of discussions, never get governments or regulators involved, but, the regulator and government has been a crucial stakeholder in having the IXP in Grenada being what it is today. That said, this model as well will be adopted because we're already speaking to IXP stakeholders in other countries in the Caribbean on how to build out and move forward with their IXP as they now understand how critical it is, given the current situation, even with, COVID-19, critical infrastructure is not present and they need that locally. So there are other stakeholder groups, there are other, another role that's performed again by a local member in the IXP is infrastructure development and policy. And there are two types of policies. There's policies as regards to pairing, and there's policy as regards to, being a member, what it takes with a memorandum of understanding, development, IXP pairing agreements, and all that. So it's a lot entailed. It's similar to like an ISP in terms of customer agreements, but we use those two key roles to ensure that this IXP runs the way it should.
So, by the way, it would be a nice question maybe for many people. So we are talking about not only switches, but there are one to multiple sometimes switches, and even IXPs might grow, and you might see in different part of the country, for example, and in many data centers, one IXP might extend. So, so there will be lots of devices, power costs, collocation maybe costs, and some people will operate this, and then not only switch. You will see now we will have route servers, we will have looking glasses, we will have lots of other, let's say, equipments, operational devices, and someone needs to manage those, okay, and someone needs to operate those for that IXP. So it should be sustainable, right? So how then IXPs are making money for all this infrastructure to continue and even grow, right? Because today maybe you have 5 guys joining your IXP, maybe a couple of service providers and just a couple maybe also enterprise business, but by the time it might be hundreds of people coming over the top providers, Google, Facebook, Netflix, Akamai, all those CDNs, and then when they come, more and more ISPs wants to come, more and more enterprises wants to come. It grows, right? So, but you need to add more infrastructure. How IXPs are making money? So let's mention about that, please. Brent, can you talk about that? How they make money?
Okay, great. So I'm going to explain two models: the Grenada model, which is a non-commercial model, but we have to survive. And also, I'm going to talk about the commercial model, that exchange in the island of Curacao, which is a part of the Netherlands. And that exchange here is AM6 Caribbean, the Caribbean branch of AM6. Now, what AM6 Caribbean does, they're for profit. They charge a monthly port fee or connection fee. So that fee varies if you're connected at 1 gig, 10 gig, or 40 gig. They charge you based on that, right? They have quite a bit of members, I believe maybe upfront of maybe 13 parent parties or even more to this point. So they generate revenue from, charging a monthly recurring fee to their connected parties. And that those fees make sense to them for being able to finance the infrastructure and support the operational, runnings of that IXP. In the case of Grenada, it's not commercial as yet. Possibility exists; it can become commercial as time goes by, and the whole value to having content sent to you locally has been perceived as a revenue generator for that organization. But what we do today from a collaborative standpoint is to have connected parties sort of volunteer their skill sets and their resources. For example, one of the larger ISPs connected on the IXP today, they provided rack infrastructure, structured cabling. The government and the regulator, which in Grenada is called the NTRC, the National Telecoms Regulatory Commission, they cover the electrical costs, and of course some other intellectual property. There's also a project that ran some years ago to develop urban infrastructure. They provided stuff like the UPS and generator for power resiliency, and power is really critical at IXP.
Yeah.
I know no failures can occur there at this point. And we have great entities out there like ARIN, the American Internet Registry, PCH, Packet Clearinghouse, and ISOC. These are the great parties. They donate high-end switches. They also lend us their support as well, in terms of their skill sets for doing a lot of development work. ISOC, again, lent a hand in the past with doing, setting us up with IXP Manager and the technologies behind that, right? So it's all collaborative. There's no profit. When there's this need for financial input, the NTRC supports with that.
So, by the way, ISOC is Internet Society, and so first model which you explained, they call it membership model, but they still charge for the port cost, right? So,
Correct.
What is the name of your model? Is there any terminology for that, by the way?
So we just call it for now. It's not for profit.
Not for profit, right? So basically, like a donation based, and some people are bringing switches, other people, other joiners, maybe bringing. Okay, let's give a rack for you. The other guys are coming and providing electricity, power, etc. So you are not charging to any participant yet any port cost or something.
No port cost.
No monthly, yearly recurring cost, etc. Okay.
None. Yeah.
Okay. Let's continue. Excellent.
Great.
So far, very clear.
Right. So this slide basically shows who we engage and who we deal with on a regular basis for ensuring the operations of the IXP. And this chart shows just a brief overview of our stakeholder model, and who the critical entities are on the IXPs and who supports it, right? Of course, we have ISPs. In the case of Grenada, there are 4 to 5 ISPs. We got a few local CDNs and some global CDNs. Today, I can openly say that we run Akamai at the IXP, also Cloudflare. There are talks as well with Facebook. Keeping in mind, some of the larger ISPs in the islands are already running their own CDNs partnership with, Facebook, Google, Netflix, and that's one of the reasons why, we were not able to actually have them at the exchange. But there is the option to do those CDNs at some point in the future. This is part of our collaborative effort and future upcoming discussions.
So basically, you said 4 or 5 participant ISPs in your IXP, right? So, and what you are saying, the same of those ISPs also, they have CDN partnership with Facebook, Netflix, etc. And basically those CDNs coming into the ISP network, Internet Service Provider network. That's why they are not in the IXP yet, because IXP, I think at the moment, we will see, I think, statistics as well, is not generating enough bandwidth for those CDNs to come there.
Correct.
Yeah.
Correct. Yeah, that's a very good point. I think the ISPs were already at a further stage of development for connecting to CDNs at 10 gig and 40 gig way before the IXP was developed to sort of have that infrastructure to accommodate them. Having things like redundant power, having their full allocated IP address blocks to provide that sort of critical IP infrastructure for connectivity.
Are they pushing this kind of policies, by the way?
Sorry, repeat.
Are they looking for this kind of policies?
At this point, I would say no. I would say no. I don't think they really care so much about that, but more so just having the right infrastructure to connect that. But I think no, with our collaborative approach, I think in the near future you will see some sort of agreement to have some of the critical infrastructure migrated to the IXP as well.
So one question actually, I was wondering this one when I found, let me ask. Uh, for sure, yeah, you don't have to answer as well. Uh, let's say out of those Google, Facebook, Netflix, etc., which one would be the hardest to bring?
I can answer that. To be honest, in my past role working for ISPs in the Caribbean, you know, a lot of my daily routine was optimizing and managing onboarding of in CDNs as well. I can tell you that the largest one to get to an IXP from a Caribbean perspective will be Google, and
That is largest
I say
one,
that
but
because
largest one, right? Of course, but the hardest one. I mean, you are calling them
la-
come, 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 but they probably push you some bandwidth requirement. What they are pushing you, what they are looking, etc., and which one is the hardest?
Yeah, so right. So I would still say Google. Google is the largest and hardest. Simplest to deploy, but hardest from the perspective that Google's requirement is at least maybe I think no, it used to be 1 gig minimum Google traffic to get at Google Cache approved. But Google caches require the largest amount of cache fill. I would say minimum of 1 gig, 1.5 gig to date. The IXP doesn't have that cache fill capacity to actually warrant us onboarding Google onto the IXP, and that's the challenge. Cache fill, you have to pay for. Cache fill is not free. Cache fill is transit capacity that comes from a selected or a group of ISPs that you have to pay for to fill those caches with popular content. And most of the people here would probably know that, and it comes at a really high cost.
So
And,
what
and
what
that's one of the reasons
basically
why.
what basically you are saying is they are looking, I mean Google case, they are looking for minimum 1 gig for cache fill, which mean for their transit capacity at least 1 gig you need to pay as IXP or ISP. Is it true?
Yeah, yes, but in our case, the IXP will have to foot the bill for that level of cash flow. And keeping in mind, it wouldn't just be Google alone; it would be the other CDN providers that's there, which would mean that my cash flow, our cash flow for the exchange would be much more than a gig.
Sure. But
Yeah, so
are all of them looking for this? I mean, Google, Facebook, Netflix, all of them, are they asking for IXP to pay their transit cost?
no, I'm glad you actually asked that question because going back to the ISP model, what we would have done then is just a simple agreement. We provide power, cooling, smart hands, and cash flow capacity, and that's it. Now, to have it at the internet exchange, I can tell you most times, we're told this is a requirement, so you need to be able to provide to have the caches. So I think this brings a good discussion and probably for engagement again with the CDNs on the cash fill requirements or allocations, because what happens in other countries and other IXPs, the ISPs, you can get them to volunteer, even though the caches are at the CDNs. Sorry, even though the CDNs are at the IXP, you can actually get the ISPs to volunteer to do cash fill on what we call an annual or triannual round robin basis. For example, ISP number one can provide cash flow to the IXP for maybe 3 years. Then after 3 year term, another ISP provides cash flow. So that is something that actually that happens for Akamai at AM6. Um, and it's something that can probably work here in Grenada as well. But I'm glad you asked that because this is something that I've really got to look at, going forward in terms of CDNs and cash flow at IXP.
Excellent, excellent answer. Okay, let's
Oh
move on.
yeah, yeah. Okay, and I want to mention as well too, on the line our stakeholder team, we're also part. the IXP stakeholder group, myself as a parent coordinator, and the other gentleman there who serves as policy and infrastructure coordinator. We're part of the Caribbean Network Operators Group, CaribNOG, just like you have your NANOG, your NOGs, your Network Operator Group, and we're also part of the Caribbean Internet Parent Forum, or the Caribbean Parent Forum, where we try to meet annually and sometimes, 4 times a year, biannually, quarterly, to have meetings to discuss driving further development of critical infrastructure like ISPs, and discussing, critical, critical areas that benefits internet communities locally as well.
Are you guys
So
are you guys publishing the videos on YouTube somewhere?
Yeah, the copies from the CaribNOG sites will have some videos from our meetings, so I can probably share these with you.
Thank you.
After the meeting here. Yeah. Okay, so operations resources that we use IXP Manager. It's probably maybe 4 to 5 years outdated, needs an upgrade. IXP Manager is an open source application that helps us manage everything on the IXP, from IP addressing of current connected parties to the connected interfaces, to traffic utilization. That's a critical piece. That's why it's number one. We do share automated bandwidth utilization reports to the connected parties, so they can see how they're performing, how they're not performing. As a matter of fact, one of the connected ISPs is currently working on migrating their port from a 1 gig port to a 10 gig port, because they have been developing their last mile or end user database and connectivity base, so they want to ensure that they can cover their traffic needs. Of course, we use low latency switches. When we just started in 2011, we used low end switches, which were all Gigi switches. Now we use switches that are using that are pretty much used on financial exchanges as well, low latency, and they serve from 1 gig ports right up to 40, and in some cases 100 gig. We're currently multiple 10 gig port IXP, with some options to 40 gig, but more so towards the CDNs. We have a road collector as well that collect roads from all connected exchanges, just for checking changes in road withdrawals and road advertisements. Plan is to do a proper road server, because we currently have maybe 13 to 14 entities, not all are ISPs, but we want to ensure that in the future that connected parties can have single parent relationships, which is going to be strictly to the, or as an alternative pair, have pairing to what we call a road server, whereby all the roads on the exchange will be served to them, as opposed to doing individual bilateral pairing arrangements. I mentioned we have a dual stack.
Just a second. So before dual stack, at the moment you don't have route server. How they are doing the BGP peering with them? Everybody's.
Right. So currently, every party that's on the exchange, signs off on a pairing agreement to the party they are interested in pairing with. So it's non-mandatory, bilateral. So if I have 10 ISPs or 15 entities I want to pair with, I have a separate agreement. I pair with them. I can choose to pair with only two. Maybe the 2 out of the 15 that I'm really concerned about having connectivity with, I pair with only those 2. So they would all have an IP address assigned, of course, from the the internet exchange resources, and they would pair bilaterally to that party. But what I've noticed is that most providers, especially the small ISPs, and of course they would want to pair with everyone, because they would want to save on transit costs. So they would probably set up maybe 10 parent arrangements, and network engineers wouldn't mind doing individual parent for maybe 10 other entities. But when it starts to grow, really and truly, you want to pair with one entity that would give you all those routes. The reason why we've started deploying and developing a road server, but the reason why it's not in full implementation yet is because we want to ensure we follow the guidelines of road server pairing. Now, road server pairing is sort of tricky, because you have to ensure you run things like I think route reflects server options, which we need to have the correct operating system. We don't have a device built out yet to do that. We're looking at other options with Quagga and Bird, but that's still work in progress.
Route server, for the route server you are talking
about. Yes.
Okay, let's move on. I got the point.
Okay, great.
Actually, let me ask one question here at this moment again. Sorry for the interruption, but for the peering LAN, so you are assigning an IP address for those participants from the same LAN. What is the size of the subnet of the local area?
Right. So the size of that subnet is a /26 block. It'll give it. We just allocated 64, 62 IPs for pairing for members. And the reason we did that is because our allocation from the regional internet registry, we can get no more than a /24. So we had to split that /24 into 4 /26s.
Okay.
And allocate them differently.
Interesting. Now that /26, I think public IP address block we are talking about, IPv4 public. Mm-hmm. So did you get it from one of those ISPs, participant ISP?
Great question. So when we just started, as an entity, we didn't have what it takes to get an allocation from ARIN, but we got a /29 or /20 from an ISP, and that we used that from 2011 up to 2014, and from 2015 we got our own block from ARIN, and we had to apply for that block. So we went to the internet registry, we filled out the application online. Thank goodness there is what ARIN calls a micro allocation in their number policy, resource manual for providing, allocation for special entities like IXPs, and so we were able to get a /40 P6 block, a /24 IPv4 block, and of course an autonomous system number as well.
That peering LAN, is it reachable from the internet?
Yes, it is, and that is something where we're actually working now on changing. Where the thing is, and other IXPs model from that, because they applied for 2 blocks and they were successful in getting it. One was used for management, and one was used for common services. There are a couple IXPs in the Caribbean that that has this sort of model right now, and part of our development is actually to change that. It's a struggle right now to get additional V4 space from ARIN because they're pretty much out of V4. So option is to use a private block for IXP LAN and use public only for things like cache fill and remote access as well. So yeah, this is something we're looking at in the near future. So however, we do implement policies as well to ensure services are secure and special ports, access ports are locked down as well.
Okay. If that LAN is reachable from the internet, so basically you are advertising it through one of those participant ISPs.
Correct.
Okay. So let's continue, and probably more questions will come up.
Definitely. Okay, so here I'm just giving a list of some of the parent parties. Now, most of these parties, if not all, are already on pairing DB, and you have I pretty much nailed out who here are ISPs and who are providing anycast and who are CDNs. I think one of the entities I'm missing here is actually Cloudflare. Cloudflare is one of our larger CDNs as well. But this just shows we're growing today. Our last member who actually built out their parent point within the IXP is the government of Grenada. They recently acquired their AS number and IP resources, so we're actually working now with them to actually get the deployment done and connectivity there.
So for the Akamai cache fill, is Grenada IXP paying for their cache fill?
Good question. So this one is pretty much collaborative because let me give you some background on that one. The Akamai cash flow is provided by one of the ISPs here at AS46650. Traditionally, all Akamai CDNs were at that particular ISP. For that ISP is a regional ISP. They exist in every Caribbean island or every Caribbean country. All the Akamai caches sat in those ISP data centers. So we had a discussion with, when I worked at the ISP there, we had a discussion with Akamai, and they said, we want to continue working in development, sharing content in the Caribbean through our caches. But in good faith, we'd like to ask you, seeing that ISPs are now growing in the Caribbean, we'd like to ask you if you can move at least two of our caches to an IXP to show that you actually are, you're supporting that initiative as well.
Yeah.
So in Grenada, we moved the Akamai CDN from AS46650 over to the IXP. The same was done in Trinidad, and more likely than not, the same will be done in two other Caribbean countries in the near future once the IXP gets going.
So basically, what I understood is the Akamai was in the cable and wireless network inside.
Correct.
Then cable and wireless basically gave it to you, and you deploy Akamai CDNs in the IXP now.
Correct.
Okay, why then the other CDNs, other content providers are not doing the same?
Well, that's a really good question. We've been thinking about that. And now that I think in the past the infrastructure would not have supported that, but now it will. In the past we were just 2 by 1 gig. Now we're N by 10 gig. So the infrastructure can support it now, but I think it's a case now of more so doing a re-engagement and having that discussion.
After this video, definitely they will consider. I can think.
Yeah, because this video will be shared.
Yeah.
So, but that's a very, very good point you made. I think given the infrastructure readiness and given how important it is to have critical infrastructure shared to all local entities in critical times like these, that would make sense. And to answer your question, so the cache flow came over with the Akamai cache movement, right? So that's how it happened. But again, this model will work for any CDN, so it's something we definitely should look at and will look at.
I will ask about the redundancy of your IXP, but I think we have a topology for that. We will see that. So that's why let me keep that one for now.
Okay, great. And of course, we encourage parties to register their entities at GREX on ParentDB as well. So everyone have a look at the common policies, because not all entities are open with their parent policies. Some are selective, and you have to have a discussion with it. All right.
So by the way, for that one, let me add a couple, like 30 seconds, very fast, some comments. Can you go back to previous slides? So we have peeringdb.com. If you are new to the peering, just start maybe from there and have a look at peeringdb, put some AS number. If you don't know AS number, put the company name, which maybe Google or whatever you know, and have a look at most of those anyway. Companies have their record on the PeeringDB. So we have anyway 3 different databases globally in this peering ecosystem. PeeringDB is one of them, IRR database another, and RPKI another. I will ask about RPKI also, Brent, what they are thinking, etc. We'll talk about that. But this PeeringDB could be your start point. Also, Brent at the very last word, he said peering policies. He said open peering. He said also selective, and we have also restrictive. 3 different peering models actually we have. So open, I want to peer with everyone. Selective, I want to peer, but these are my requirements, generally high requirements. Restrictive, actually I can peer, but I know who to peer, just generally tier 1s. So tier 1s follow this restrictive model, so you can, whatever you do, you cannot peer with me if you are my customer. So you should be tier 1, and tier 1 knows each other. Tier 1 means they are not paying to anyone for upstream traffic, by the way. So for this kind of basic, very basic stuff about the peering. If you type orhanergun.net, you will see my website, and there are many posts also on the website about peering, private peering, public peering, those terminologies, and bilateral, multilateral peering, tiers, tier 1, tier 2, tier 3, those kind of things. Let's move on now.
Okay, great. Great. So, of course, now, when we look at development and expansion, we're thinking of the education sector and remote working. So even before COVID-19, we had this plan to look at, who are going to be great providers to have that, benefit, teleworkers and a lot of the cloud users. We know that Office 365 is really important to a lot of businesses here. So we already engaged, as a matter of fact, Microsoft on their Azure current service. It's still in discussion with them. They did reply and they let us know that their team is looking into it. This one would require some partnerships, of course, with the ISPs, because this is a for-profit sort of connectivity. But Microsoft does this with a lot of the larger provide ISPs in the world, right? The Verizons and Sprints and so would have these, but it doesn't hurt to ask, right? There's also a team in Miami that focus on education as well. They want to host some of their educational content locally as well for the Caribbean. What's important to note as well, given the ISPs that are connected here, all right, and they all have, let's say they exist in maybe 16 countries in the Caribbean. Their connectivity model, right, is one that sort of appears like a regional IXP, because they have low latency links to each other. They connect each other at 10 gigs. So you would find the round trip time, let's say from the IXP in Grenada to another Caribbean country that's connected by that same ISP, it's less than 50 milliseconds. So that's not bad for voice services, web conferencing. So then that's something unique that we have here, which we want to sort of benefit from by hosting these services. So I'll move on to, I think, your favorite part, Orhan. This is a really high level of what's there on the Grenada Exchange. Not all connected parties are there. I just put a few, which are the ISPs and the level of connectivity they have, and sort of just to show the layer 2 switch fabric. They're all layer 2 devices that's providing connectivity for the pairing LAN, common VLAN, VLAN 1001, and of course, the type of connectivity they provide, which is 10 gig, 1 gig, or N by 10 gig. I'm sure that you may have some questions on that. I did show the road collector as well,
yes,
which is open for public access. If you can log in and pretty much take a look at the roads that's there. It's due for I think an update, because there's some new entities that are in there that's not really pairing with road collectors yet. But that we will work on in short order.
I think this you were talking about this layer 3 fabric. This switch at the bottom of the page, it's showing that one, right? DC firewall. It's connecting to layer 3. Then that switch is also connecting to the Akamai CDN, so for the cache fill.
Correct.
Yeah, other than that, very obvious. So we have ISPs. They are, some of them coming as 10 gig, some of them coming as 1 gig, and connecting to the connecting here to the our layer 2 switches. And then for redundancy, what you are doing, that's an interesting point we need to talk. So are they just connecting single switch, or are you putting some optimal cross connect before them, like Amsterdam model?
Okay. Very good question, and I'm glad you asked that, because it is something we want to sort of drive home to ISPs. It's not because it's a connectivity you can do without it's not like a critical connectivity for you, but it should be. And some providers, I think one provider to date has dual connectivity to redundant routers in their POP or their central office. and they connect to separate switches at 10 gig. We're trying to sort of, and they're doing that on diverse routes. So there will be separate fiber routes coming to the internet exchange. So they have redundancy as well. Not that's the only provider that does that. It's just Cable Wireless and other providers I think should try to model that, even though it's at 1 gig. It's important to have that kind of connectivity because failures do happen. While our failure rate is very low, we did have an electrical problem that was stemmed externally at one point that actually took a switch out for 4 or 5 hours. So it's, and again, you would see ISPs there being served maybe within maybe 800 megs to 1 gig of content that, really and truly, depending on the type of content, it may have been important to someone at that time. So our story here is not just have redundancy on transit, but have redundancy on the internet exchange as well.
So I probably missed some points. So here the ISPs and participants, are they connected via single cable to single device or two cable to two of those switches? How the connectivity? I didn't get the point there, really.
Okay, so one ISP connects to two separate IXP parent LAN switches via two separate fiber links at 10 gig. All the other providers connect at one single fiber to a single switch. And in some cases, just to have diversity, we simply move maybe one connection to, so we wouldn't have all connections on one switch. Maybe provider X would have.
What if let's say if I am connecting to switch A and you need to do some maintenance on switch A? What is your model to move the traffic to switch B?
Okay, great question. Today, what we do is just pretty much send out a maintenance notice. And because the ISPs can actually, perceptually as well, do without a connection for some amount of time, then it's fine. For now, we simply move that connection onto a separate switch. All right. So for now, and that again, I'm glad you're asking that because this will help define how this model looks like in the future for having a really low mean time before failure. But today, single connections, we send out a maintenance notice, and we actually move that connection over to another switch.
Now,
but in most cases,
yeah.
Go ahead.
Actually,
in most cases, our maintenance have been just software upgrades, which is sort of ISSU typed. So it's really a very quick change. So sometimes we don't physically move because it's a very quick change on the upgrades. But you were asking something, Orhan. Go ahead.
Yeah. What if they don't read your email? And are you forcefully then tearing down the BGP session? Which we have an RFC now for that. So not voluntarily. Yeah. So you are not doing that kind of things. Then you are expecting, because not much number of participants anyway. So probably you could even reach out to them for the maintenance. But for the larger IXPs especially, it's very hard to know if everybody read that email, and accordingly maybe if they have another IXP connectivity, move your traffic to another IXP for, let's say, content if they are reaching to, etc., etc. So yeah, it would be hard in this case. So okay, let's talk about this. You have firewall also there, as I can see on the management.
Yeah. So this firewall is it's for out of band management. Also there is a full rack of virtualization components there, right? Hosts and VMs that are responsible for certain things. For example, IXP manager sits there, monitoring service, open source monitoring service like CACT, some other commercial ones are in there. We also have a few critical services in there as well.
Like what are
that
you
requires
monitoring? What are you monitoring with the CACD? You are monitoring with the traffic statistics, etc. Right? Anything else?
Correct. Correct. Traffic statistics also, we use it as a tool to do sort of failure notifications as well. So, for example, if a connected port goes out, or we can't reach, say, the ISP's parent IP, then an email would go to that ISP and to the IXP management team as well, notifying there has been a failure.
Okay. So another thing that I want to say for the whole audience later on. In this model, only one ISP, as Brent says, connected to two of those switches. And if multiple of those people would be connected to two of those switches, and if there are more participants, and if you want to do a maintenance on one of those switches, generally two ways we have. Either those participants, they are connected to cross-connect device optical switches, and very fast switchover happening with those. And another model, basically placing layer 4 access list and then basically dropping those TCP 179, which BGP runs on top. And that feature is called session culling. And some of those IXPs already started doing that. But in this model, in this design, we have very few participants, though it's growing. Akamai is there, guys. And so traffic is getting larger and larger, which will probably attract other companies as well. Then they need to look at this redundancy again and again. I think so, yeah.
Yeah. We don't want to, as you mentioned, that there is an option as well, which we're looking at for the ISPs with single connections, is to frontline them on a layer 2 interconnect that would already have dual connectivity to the other two switches. The only reason we really haven't pursued it as yet is because that switch is just limited to 4 by 10 gig ports, but we need to ensure we have a full 1 gig, 10 gig, 40 gig switch.
Optical
so
switch.
That is already a plan.
Optical switch.
Optical.
Is it expensive compared to Ethernet switches?
Yeah, it's pretty expensive. You're talking about switches that would cost anywhere from 25 to 40,000 US. But our good friends at Packet Clearinghouse, donated quite a few of those. And I say quite a few, meaning 3. Donated 3 of those first, and we're really happy with that. Something I did mention though is that while what we do, we ask providers, when they indicate they're going to connect either by 1 gig or 10 gig, they bring their optical units. They bring their SFP or SFP plus. So we do have a stock, which we try to keep there for emergency purposes. But and it's very cooperative. No issues. They will ask, okay, what SFP type, and we just tell them it's outlined in the parent agreement.
Yeah. Cool. I am fine with this slide as well. Very clear. It's 26/26 you mentioned, IPv4 and /64 for IPv6 you have, and that AS14432 is IXP's AS. So Grenada Exchange is his own autonomous system. As you can see, it is public AS, not 2-byte private AS. This is 2-byte public AS. So, and this one, why you are using at the moment, if you are not deploying route server. So if participants already peer, why you have that?
So it's critically important to have this for the route server. For now, we do use it on the route collector as well.
Okay.
Right. So so right now the route collector pairs with everyone using that AS.
Yeah. For the route collector, it with this AS, basically GRX. Are we saying GRX? GRX basically peering with the all the participants and get the prefixes from them, and I think your route collector is accessible publicly, so we can check if I want to join Grenada Exchange, which prefixes I can reach out from Grenada Exchange. It's like also marketing tool for the
Yeah.
IXCs. So for the Internet Exchange route collector, if I connect to, he basically shared in the beginning of the presentation. If I connect there, I will see what are the prefixes I can reach out, and then basically I can decide whether this Grenada exchange is beneficial for me to join, because how I will know, I know which prefixes can be reachable from GRX, and then I know, of course, through, I don't know, S-flow, NetFlow, IPFix, etc. I monitor my traffic statistics from my network, and okay, 80% of my traffic is accessible from GRX, let me join, or etc. This kind of decision can be made. Route collector is important. So at the moment, although they don't have route server, probably in the future might be, route collector is also using public AS number to peer with those participants. Let's move on. Very nice.
Okay, great. So I had a slide here just to give an illustration of, the non-mandatory bilateral pairing. The dotted green line just indicates sort of a BGP pairing session flow between parties. So, this pretty much just gives an outline as well as, it's a low latency fabric, right? Here I actually had, it's just a illustration of what the latency packet loss and jitter looks like from one device on the fabric to another.
Just a second. I mean, still try to figure out everything here, what's happening. So participants are there, and then the dotted green lines showing what?
They're showing eBGP parent sessions
okay.
from some of the,
So basically, we are seeing that not everyone is peering with each other, but who is peering with whom, right?
Yeah.
So can we say everybody wants to peer with the content provider?
Yeah, everybody wants to. And this requires some updating as well. One provider actually had an issue, and now they're coming back on not 1 gig anymore with 10 gig. So we got to get all their sessions reestablished. They're coming now with a new new IP address block. So there's some renumbering we have to do on the pairing to them. There are existing sessions that we need to update. So
this one, yeah, let's make this one also clear. Would be great, I think, after this. So this Akamai, it says, and I think these are Akamai servers, right? And connected to the routers. These routers belong to who? Akamai.
That's on the top. So correct.
Yeah.
Akamai was provided their own routing.
And then that router is connected to the switch, and here this left bottom left switch is belong to GRX.
Correct. Yeah.
Okay. So
well.
and then at the top we have CWC, Green Dot, iCellCom, and Digicel. These are, I think, 4 of those ISPs.
Correct.
They have their own routers, and they are also connected to the switch. But what I see here, Green Dot, for example, doesn't have eBGP peers directly with Akamai, but it's peering with this CWC. Why?
Right. So, this is excellent. So Green Dot is a downstream customer of CWC. And just to tell you, their routers actually sit at their central office or their POP, right? And they have their fiber running directly into the exchange. So their routers do not actually sit at the internet exchange, but it sits at their connected to the exchange optically, right? So Green Dot is a downstream customer of CWC. CWC provides IP transit for Green Dot. Now, I believe, Green Dot actually has a session to CWC over the IX as well. But I think initially they were working on a routing issue. They were also getting routes from both parties. I think one over and that's all going to be in policy. They were getting routes from CWC, and they were getting the same routes advertised to them over the internet exchange, right? So I think it was a case of transit paths. They already had direct routes to CWC, and they also had a route to CWC via the IX. So I think they temporarily shut it down to do some work on the optimization. I have to go back and check the status, and I will
Okay,
update this
I
diagram.
can understand what
But
you are saying, but Green Dot in this case, although it is the downstream customer of CWC, since Akamai is accepting, Akamai is okay to peer openly peering with the Green Dot. Why Green Dot, although it has a transport connectivity to your switch here, why Green Dot is
yes,
not directly peering with the Akamai then?
yeah, and okay, so I will have to give you some key information here. Green Dot would be running their Akamai service as well, hosted Akamai services through one of the neighboring islands. Um, it's only, it's in terms of latency, it's only maybe 10 to 15 milliseconds away from them. So that provider operates a large operation, the larger part of their operations out of another Caribbean country that is very close by, that hosts their own Akamai servers. So
Okay.
I think
What
their
I,
train of thought is to take the Akamai content from their own caches.
So basically, Green Dot will have settlement-free peering in different IXP with Akamai, and they will continue to get probably transit service from CWC from Grenada Exchange.
From Grenada, well, transit service from CWC direct.
Yeah, CWC, Green Dot,
Yeah.
I said that. Green Dot
Yes.
will get the transit from CWC. So basically, which explains GRX is not participating if someone is selling IP transit in the IXP. So
Yeah,
generally,
correct.
IXPs don't interfere with that, to be honest. And GREX also, GRX also is not doing that. So people, if they join, they can do private peering, they can join peering LAN, they can sell IP transit, they can sell partial transit or paid peering, if people call it.
Yeah.
So they can do all these business models, it seems. Excellent. We are going well.
These are good points, Orhan, because we have to ensure that our policies and are clear. That on the X, no default routes or full routes and tables are accepted. And so it's quite a bit of work managing that stuff.
So basically,
Okay,
how just for that point, how you are how you make sure nobody can send default route to each other?
Okay, so and for non-mandatory bilateral pairing, right? We can all, we urge the providers and they got smart engineers, so they know what they need to do. But we still, send a note saying, guys, when you're exchanging with each other over the GREX, please ensure the below list are considered in your policies, which is, not only advertising local routes, how to tag with no community
Filter bogons, those kind of things, and default route also. You are warning them basically, but you are not filtering anything.
No, we're not.
Okay.
We're not filtering anything. Of course, once we do our road collector and road server updates, we do want to have the option to have full routes and tables as well, just for integrity checks. So,
sure.
But we will adjust our filters to suit on those. Yeah.
Okay. What else we
so
see?
So this slide, we're just this sort of sums up benefits of the IXP. We started in 2011, it's 2020. We're showing how the traffic level really grew. And the traffic level grew because we actually brought on CDNs. Yeah. I think apart from the CDN, local traffic exchange is probably maybe 300-400 megs, no more than that. But it's the content that's actually driving the growth of the traffic on the exchange.
By the way, for even those participants, ISPs, their 80% of the traffic would be towards the content providers and CDNs.
Yeah, so exactly. So most of the traffic served to these ISPs is CDN traffic. Yeah. And it's interesting because this model I think wouldn't change. I'm looking at current stats now because in the past entities and maybe research entities, government entities might ask, can you tell us what type of traffic that's on the exchange? And we do not do any form of packet inspection, no DPIs. maybe net flow if we're troubleshooting or we need something urgently, but we do not do any packet inspection. We can't tell providers or hosts, or we're seeing traffic from your source IP addresses going to this particular destination. We don't do that at all.
Sure.
No application recognition stuff. But we can tell you that most of the traffic is served via CDN. And in looking at CDNs and looking at CDNs in general in the Caribbean, and specific to Grenada, so let's take, for example, Google, Netflix, Facebook. We would have thought, maybe with COVID-19 and, end users asked to stay at home and on mandatory, curfews and all that, we were thinking that most people would be there looking at, movies and all that. But we've seen the jump of, Facebook traffic more so than Netflix viewing, so it's, Google remains the giant, Google is, Google/YouTube is the giant, but, there's a lot of personal communication going on, sharing of, so,
when Google come there, it will be a huge spike, I think, especially those GGC nodes, Google Global Caches. So there will be a huge spike. Hopefully they join as well, and Grenada Exchange grows even more. So what else we will talk? There are a couple questions, by the way, we can go through in the chat window we have. So I think we will see some statistics, I think.
Yeah. So these are show. I mean, I'm sorry I couldn't give you data from since 2011. We were monitoring since 2011. That would have shown you traffic moving from 5 megs up to date, but with a lot of change in infrastructure, and at that time, no deployments of virtual machines with these monitoring tools, we couldn't really, fail this data over, save it or anything. But going forward, we should be able to give you data annually.
Okay, excellent.
This just shows the current traffic rates, and I can in the future split this up to show you what's being fed from specific CDNs or from specific providers. But to date, we can do that, but I didn't really share those slides, but I can.
Okay, fine. We have around 2.5 gig peak traffic, it seems. Okay, benefits.
So there are lots of benefits, and I think the benefits would differ and be different based on the country you're in. And I should have mentioned, Grenada is not the only Caribbean IXP. There are IXPs in Trinidad and Tobago, which has a great working model. There is AM6 Caribbean in Curacao. There is DANIX in the island of Dominica. There is SVGIX in St. Vincent. There is FLIX, St. Lucia Internet Exchange. There is Open Connect in St. Martin. So, BVI, there's BVIX. BVI is sort of a, UK-based Caribbean territory. It's called Tortola, it's the British Virgin Islands. There is also an internet exchange there, and TIGA is working on their development. So IXPs are really, really growing in the Caribbean. So you would find the benefits may differ, but there's a common benefit. Your locally generated traffic stays local. That's the first rule and most important one.
That is very, very classical saying. That's true for sure. Locally generated. Let's say if it's generated in Grenada, it will stay there. Yes, but also we should add maybe here to first benefit. Even most of the, of course, content is generated in the North America, but those contents also will stay locally in Grenada when you have the IXP, let's say that, because those contents will be pushed to the IXPs. If it's in Grenada, it will be in Grenada. I am in Turkey, so if you have IXP here in Turkey, so, and if you can bring those North American content to your IXP, then now not only local content which is generated inside that country, but also even if it's generated in North America, will be brought to the brought to your IXP, your country. So stay local. Okay. So only one copy of the traffic is which we call that one cache fill. So one copy is brought. Let's say your favorite TV series. One time will be brought, and then after that, thousands of people, if not millions, will watch from the local IXP, or if that CDN in the ISP, from that ISP. That's excellent point. Yeah.
Yeah. We do, provide you accurate reports of your utilization. And that's sometimes a good thing to have. You want to have an idea what's being exchanged locally. You can measure it yourself as an entity or an ISP, but, you get that benefit as well. Um, you know, uh, I think it's a really helpful infrastructure to support local businesses. And some businesses try, and even startup businesses try to develop services that can be served locally. That's a good sort of stimulus for them because they have an infrastructure to share it on. Um, Again, if you're an enterprise and then you've never really worked with BGP because you're on an ISP, then you have an opportunity to learn about BGP and actually use it, right? And again, here, with IPv6 been around quite a while, but like MPLS, took some time to get big in the Caribbean. This is an opportunity for you to actually get connected um, locally via IPv6 and actually use the protocol. And actually, for me, this is a great opportunity because I'm an IPv6 evangelist. I believe in the protocol. I'm hoping to see more accessible content. Working over V6. Today my favorite websites are all V6 enabled. So from time to time at home, I simply turn off V4 and I use V6 only as much as I can. At least to just generate some traffic. But these are some of the key benefits that you can get today
Okay.
on connected to GREX.
Okay, that's cool as well. And in fact, I mean, not only uh, just specific to Grenada, maybe, but definitely I suggest you guys have a look at articles from orhanergun.net also on the IXP benefits in general. There are, of course, many doing peering, settlement free peering. There are many, of course, not monetary cost. Monetary cost may not be even sometimes benefit, maybe sometimes because transit cost is decreasing very gradually in some countries. Not cost, I am not talking about cost, but having probably optimal routing and reducing the security threat, number of basically threats point, attack points, and plus also latency point of view might be better. So better routing, optimal routing you might have when you have IXP. These are some benefits. Also, I should say that there is only one book written just pure for the peering and of course not only settlement free peering but peering ecosystem in general. Bill Norton, it's nice book. And also for the service provider network design and architecture, not only peering but transport networks, but real life creating one large fixed and the mobile provider from scratch and with the many services. There is only single book. The guy named Orhan Ergun wrote that. Service provider network design architecture. So definitely you should also get that book as well. So we are covering peering and much more stuff that in that book as well. So two books for your service provider IXP understanding I would recommend. Are we talking about any other thing?
Um, it's it's always good to highlight a few challenges, but
Okay.
the benefits far outweigh the challenges. The challenges you can always work on these challenges, right? Of course, we're continuing to look at how we can drive CDN deployments on the Grenada Internet Exchange for the benefits of serving more beneficial local content. Um, educate more stakeholders on why it's important. And I think now with COVID-19, they're actually really seeing the importance of having critical infrastructure at home that would serve in the event that you get cut off, right? Um, Again, ISPs need to consider IPv6. I've been on that trail since 2009, uh, trying to work and educate and help, drive deployments in Grenada and the rest of the Caribbean on the whole. And we've made some progress, but there's lots of work to be done, and that's on the sides of the ISPs. You'll find ISPs are they already acquired their resources, they're already transiting, but some of them are not actually deploying to customer on their access links as in broadband connection. So that's one thing that has to change in the near future. Again, collaboration can be a challenge. Most entities only look at a competitive aspect. You know what I mean? And it's yes, you have to make money for your business needs to make money, but if you strip down the actual benefits and you look at them closely, there is more to gain. It's not a hindrance. There is more to gain by pairing on a well-developed IXP than not pairing. The bigger, I would always say, the bigger ISP will always. I don't even want to use the term win, but the bigger ISP will always pull and drive more content because they're simply the bigger ISP. They have more
Yeah,
end
yeah.
users.
When it
So existing
reaches
eyeballs. Yeah.
when it reaches to critical mass, yes, everybody will basically ask to be there. They would like to be there.
Yeah.
Critical mass is important.
Yeah. And now, and it's interesting. I remember years ago, maybe 4 or 5 years ago, I was actually working on a customer's network, and he wanted to get some side-to-side VPNs done. Um, the two ISPs there was maybe three ISPs connected, four ISPs connected on the internet exchange in that country, and his side-to-side VPNs were perfect for the entities connected on the ISPs because, of course, better round-trip times, faster connectivity. But the ones that were not on the ISP, and then he had to go through the US and back to get in, problems. So I think this is a gain for providers. So there are more benefits. And at the end of the day, if you're not the largest provider, the largest ISP, you still get your end user still gets a good quality of experience, and you still get benefits. So why not use those benefits and
Yeah,
enjoy them?
we've seen a lot of time, especially in Africa. Just two service providers, their customers are 20 kilometers apart from each other, and their traffic is going through Europe and come back. So instead of, let's say, 1-2 milliseconds, we are seeing 150, 250 millisecond latency between just two neighbors, let's say, in the same country. Because their connectivity model was hub and spoke mostly, and their hub was Europe. But now these IXPs are really becoming more and more popular, and they are deploying everywhere almost. And we have, I think, over 500 IXPs in the world and growing. Definitely, I support from many aspects these IXPs as well. So whenever someone wants to talk about this topic, I will give my time. I want to definitely highlight the benefits and how we can grow this basically ecosystem. I hopefully I can be just small part in it. Yeah.
Yeah. Yeah. And as I mentioned, we're still not for profit, and we're happy when we get volunteer support until there's some point where we can really build out the team and everyone's happy.
Yeah.
So just following on in the last slide here, again, to sum up, we're going to promote more local content as well, because we already have a couple members there, a couple entities that are doing small e-commerce stuff. There's one entity that is actually selling clothing for toddlers and babies online, and that content is right there, right? Again, we want to partner with CDNS to bring content closer to end users, and again, increase our stakeholder base to regional ISPs. And the reason I said regional ISPs because there are other countries that are very close to Grenada that is governed under the same sort of telecom regulations. So we do not want to have to, do the same thing differently, or maybe we can, but at least they can model from what is already working. So some of the smaller islands, larger islands who are close by, they're already adopting our policies, MOUs, agreements, our infrastructure design, and all that. So we'll be happy to support them as well.
Even this last point, increasing our stakeholders to the regional IXPs. There are many questions, in fact, I could ask, and there are a couple of questions also from chat window as well, like regional IXP, why you would want to connect to regional IXP, what is regional IXP? There are many things still are there to talk, and in the beginning, just before recording also, I was talking to Brent, so we are planning for the second session. This one, let's make this one introductory. So introduction to Grenada Internet Exchange Point, and we provided, I think, some information about what is peering, what is some private peering, bilateral peering, those kind of basics, and we also showed them some paths like get this book, two books I mentioned, one of them my book, Service Provider Network Design Architecture, and Peering Playbook. You can find it also on Amazon. Bill Norton. That's two books are nice for this, not only IXPs but for the ISP as well, those environments, if you want to understand more and more. So I will collect more questions based on the feedback. People will watch this video on YouTube as well. You can comment under the video guys on YouTube, and you can reach me out also, send your questions, let's collect them, and we will come together with Brent, and then I will we will discuss your question that time. We can answer those. I see also, as I said, couple questions in the chat window, but let's keep this video here. I think it's already almost 1.5 hours. So we promise you, if this is useful for you, if it was interesting, and if you want to learn more on the peering, on the IXP, on the service provider in general, let me know. Put your comment, as I said, below the YouTube video, and basically we will come together. And you can reach me out on LinkedIn mostly, Orhan Ergun. I am using LinkedIn as a social media. I am not active on Twitter much, so you can reach me out. Brent, how they can reach you out? Reach them, yeah.
Yeah, you can get to me. I would share my contacts with Orhan, and Orhan could probably post it as well. But I'm on LinkedIn at Brent MC, BRENT MC, and my Grex email is brent@grex.gd, brent@grex.gd. But I would share those with Orhan so you can post it in the channel.
Yeah, sure. Thanks for joining, Brent. It was really nice information. We provided a lot, and hope to grow Grenada Internet Exchange as well. Maybe next time it will be very close, probably. Maybe who knows, those content providers, CDNs, they can watch this video as well, and they can contact with you. And I would like to hear if that happens.
Yeah, definitely, that would be great. And I think there will be some changes maybe in the next year, on the exchange. So I'm hoping to, and I've learned a lot, guys, from this experience. So I want to say thank you for having me, Orhan. It's been a pleasure.
It was really great to have you, and we will be together again, hopefully. Thanks, Brent, again.